In this problem, we are asked to apply the integration by parts formula to evaluate the integral of e to the 3x cosine 4x dx. The challenge of this problem is on the fact that, unfortunately, the integration by parts doesn't work when you apply it just once. In order to solve this problem, we'll have to apply the integration by parts twice, and then do some algebraic manipulations. So let me show you how this idea works here. So first, what we're going to do is just apply the integration by parts once and see what do we get for the outcome. Let's choose the u and v prime here. We're going to use u equals to e to the 3x, and v prime being equal to cosine 4x. We know that we need to find u prime, which is going to be 3 e to the 3x. And we also need to find the antiderivative of v prime of cosine 4x, which is going to give us 1/4 sine 4x. Then we substitute these expressions to the integration by parts formula, which is here on the right bottom corner of the screen. And we get the following. So that's going to be equal to, our original integral is going to be equal to, it's going to be e to the 3x times 1/4 sine 4x minus integral of 3 e to the 3x times 1/4 sine 4x dx. Here, e to the 3x is u. 1/4 of sine 4x is v. This expression here in the integral is u prime, and this expression here is v again. What we're going to do here is we'll factor 3 and 1/4 out and then multiply. And we'll rewrite this 1/4 in the front of this expression. So if we do that, you get the following. So it's going to be equal to 1/4 e to the 3x sine 4x minus 3/4, again, which is coming from 3 times 1/4, okay, e to the 3x sine 4x dx. This expression here, the first term here, is in simplest form. We cannot do anything with that. But looking at the expression here, the second term, which is the integral again, and looking at it, we see that it's kind of similar to this original one, but the cosine got changed to sine. So again, the idea here is that we need to apply the integration by parts the second time, and see what's going to happen there. So what we are going to do, we're going to just take this integral, apply the integration by parts, and whatever we get from there, we'll plug back instead of this integral. Okay, so let's do that on new page. So the integral that we have there is integral of e to the 3x sine 4x dx. And again, we need to choose u and v prime to apply the integration by parts. So let's use u equals to e to the 3x again, and v prime being sine 4x. So we need to find u prime, which is e to the 3x. And v, the antiderivative of sine 4x, is going to be negative 1/4 cosine 4x. And then applying or substituting these expressions into the integration by parts formula, we get that this integral that we have is equal to e to the 3x times negative 1/4 cosine 4x minus integral 3e to the 3x times negative 1/4 cosine 4x dx. And let's simplify this a little bit. So we get, okay, for simplifying, I would like to mention that one more time, that this is u, this one here is v, this is u prime here, and this one is v again. So now let's simplify. So we're rewriting it as negative 1/4 e to the 3x cosine 4x okay, now 3 times negative 1/4 and factored out. Negative was negative is going to make positive, so you're going to get 1/4. I'm sorry, plus 3/4 again, and the integral e to the 3 to the x, e to the 3x, cosine of 4x, cosine of 4x dx. Now, this expression is the result of this integral. Okay, so we get that expression, we get this expression applying the integration by parts to this integral. But this integral itself is the integral on the second part of this expression here. So like of this expression here. So what do we need to do is we need to take that expression, this one that we got, and substitute it to here. So we're replacing this expression here by that expression. Okay? So what do we get then? So it means that that expression needs to be multiplied by negative 3/4, and you do this minus whatever you get from there. So let's see, what do we have there? Okay, I'm going to do that on a new page. So what do we have there is this. We get very, very first original integral. So it's e to the 3x cosine of 4x dx is equal to, and now we have 1/4 e to the 3x sine 4x minus 3/4 times, and let's write that expression here. So it is negative 1/4 e to the 3x cosine 4x and plus 3/4 again, and then we have integral of e to the 3x cosine 4x dx. Okay. Now we need to multiply these 3/4 by each of these terms to simplify or to get rid of these brackets. So this is going to be equal to, let's write that equal to, we're going to copy the first term as it is. So that is going to be 1/4 e to the 3x sine 4x minus, oh, so it's going to be plus, so it's going to be plus 3/16 e to the 3x cosine 4x minus 9/16 integral of e to the 3x cosine 4x dx. Now, we have the equality, or we have the equation, where the left-hand side is this original integral. Then right-hand side is two terms here minus the same integral that we have at the beginning. So let me underline this. So this is one of the integrals. This is one original integral that we have. This is the original integral that we have. And this is the same integral we have on the left. So what we are going to do is this. So we are going to move this whole term to the left. Or by other words, we're going to add 9/16 of this integral to both sides of this equation. And when you do that, taking into account that you have 1 here on the left here. So you have one of these integrals and 9/16 of that integral. So, and when you add 1 and 9/16 together, we're going to get 15/16 of the integral of e to the 3x cosine 4x dx equals to 1/4 of e to the 3x sine 4x plus 3/16 of e to the 3x cosine 4x. So the only thing that we need to do now is just divide both sides of this equation by 15/16, or we can say that we multiply both sides by 16/15. So when you do that, we get this. So we have dx here. Oops, no, we do not have. So we multiply that integral. It's going to be integral e to the 3 to the x, integral e to the 3x cosine 4x dx. And then right-hand side multiplied by 16/15. You can simplify that, and you're going to get 4/15 e to the 3x sine of 4x plus then we're going to be 15 times 3 is going to be 45. 16s are going to cancel out, so it's going to be 45 e to the 3x cosine 4x. And take into account that we need a general antiderivative, so we need to add plus c at the end. So plus c at the end. And this is going to be our final answer to our integral. So this is the result that we want to get. Now, let's summarize what we did here. So we started with applying the integration by parts to the first integral, and we got the expression that has two terms. One of them is the expression, and the second one is integral, which is kind of similar to what we had originally. So we said, all right, so let's try to apply the integration by parts again. So we took that integral and applied the integration by parts again. And we got the expression that involves the original integral. So what we did is we took this expression, brought it back here, multiplied by -3/4, and subtracted it from this term. So when you did that, we got this big expression here. And after getting rid of brackets, we get this expression here. And then we saw that the integral on the left and right are the same. The only difference is we have 1 in front of the first integral, and this one has a coefficient of -9/16. So we added this expression to both sides of this equation and combined these coefficients to get 15/16 of that integral equals to this. And finally, to solve this for the integral, we multiplied both sides of this equation by 16/15. Or you can say that we divided by 15/16. And we got this answer. I hope this helps.